All right, today we're going to look at systems of equations. So systems of equations are two or more linear equations that have the same variables. So you're going to have your x's and your y's. You're going to have a slope. You're going to have a y-intercept. The solution or the answer to a systems of equations problem is the point where the two lines intersect or where they're going to cross each other. Now, before I go through how to actually solve these problems and do an example with you, I want to talk about the different types of solutions that you can have. So, you're going to have options that have one solution, which means they only cross in one exact point. So, the different slopes are always going to have a point where they cross. You're going to have systems of equations that have no solution because parallel lines, think about train tracks, they never cross, they never touch. So, they will never have the same point, share a point in common. Parallel lines have the same slope, so they're always going to be going up and over at the same rate. Our third option is infinitely many solutions. These two overlap. They are the exact same line. Every coordinate for line A and line B is going to be exactly the same. Now, typically, the majority of the ones you see are going to have one solution, but know that you can see some that have no solutions and infinitely many. How do we find the solution? Well, in 8th grade, we only graph to find the answer to a systems of equations. As you get into Math 1 next year, you'll talk about some other ways that you can find it without having to actually graph the equation. But this year, only worry about graphing. So step 1, graph both slope-intercept form equations. Plot your B, count your slope, and connect your points. Just like we did when we graphed slope-intercept form a couple weeks ago. Step 2, find your answer. Just find out where do they cross. Where do the two lines touch each other? So, I'm going to do a problem with you. And I have two equations written. I have y equals x plus 1 and y equals negative x plus 3. Now, we can do this together. We can figure out what is m and what is b before we start graphing. Well, on this first equation, y equals x plus 1, what number comes in front of x if you don't see it? 1, so my slope is 1. My b is what's at the end. It's a positive 1. So that time slope and y-intercept were both 1. On my second equation, when I find slope and my y-intercept, my slope, well, what comes in front of this x? There's a negative sign, so that means it is negative 1. My y-intercept is going to be positive 3, so I'll just put a 3. Now, what we do is we graph both equations. So I'm going to graph my first equation now, the one in orange. Plot your y-intercept, so go to 1 and put a point. And my slope is 1, which means I go up 1 to the right 1. Up 1 to the right 1. Up 1 to the right 1. And then we're just going to connect the dots to create that line. My second equation is y equals negative x plus 3. Step 1, plot your y-intercept. So from 0, 1, 2, 3. And then my slope is negative 1, which means I can go up 1 and to the left 1. Up 1 and to the left 1. Or I could start here and I could go down 1, right 1, down 1, right 1. And then we're going to connect these points to draw our line. Now, to figure out the solution to the systems of equations, I'm going to figure out my point. Where do they cross? Right there, I can see is an intersecting point. Both of my lines cross at that coordinate. So you're going to make the coordinate. It is 1, 2. So your point, or your answer to the systems of equations on this problem, is point 1, 2.